Working solutions, the solutions that we use in an experiment in the laboratory, are often prepared by dilution of a stock solution that's at a higher concentration, that's maybe made out of convenience for preparation or because it's in a more stable form for storage. A typical procedure for dilution starts with transferring a specific volume of a stock solution, some solution with a concentration that would be given, and you're transferring it to a new container and diluting that to a final volume. Now be careful, sometimes you'll see the word diluting as part of a preparation from a solid where it's initially dissolved and then diluted. This is referring to taking a solution and diluting it. So what it would look like perhaps is a bottle that's on the shelf that's at a relatively high concentration. And we're taking some part of that solution, maybe in a pipette, just a piece of glassware of a fixed volume. And this is the source of our solute. It's dissolved in this stock or first solution, and we're transferring that in, and then we're mixing it with the solvent. There's probably already some solvent to make up this stock solution. We're mixing it with more to dilute the concentration, and what we end up with is a solution of the same solute but at a lower concentration. Let's look at a couple problems. In each case, as we solve these problems, we're going to be using a dilution equation. M1 V1 equals M2 V2. In these problems, we're going to see volumes and concentrations that are associated with one another. In this case, I'm going to go ahead and label this as the first condition. So how many milliliters? I'm asked for V1. This concentration, I'm going to label it as M1, goes with that first volume. They're associated. There's a second set of conditions after the dilution has been performed, where we have another volume. This is what it's been diluted to, and another concentration. The most common mistakes in doing these types of problems is mixing up which volume and which concentration go together. In this case, we're asked to solve for V1, so we'll do some simple algebra, divide both sides by M1. So V1 equals M2 V2 over M1. And then you plug the numbers in. Now, one of the interesting things about this M1 V1 equation is that when I take that volume times the concentration, that's effectively giving me a number of moles. That's that amount of solute that was in the pipette that is the same as the amount of solute that's in the resulting solution. Because we have the same setup on each side, however, we don't need to be as specific about the units as we do in dimensional analysis, and we don't need to change to liters. We can leave this in milliliters, or if it were in microliters, or if it were in gallons, as long as the two units are the same. So my concentration, and this is the same true of the concentration units. So my M2 is that 8.0 times 10 to the negative 4 molar. My second volume is 100.00 milliliters. Those were the two that were a pair, and the concentration of the stock solution I started with, in this case, goes on the bottom. The molarity units cancel. Again, if they're the same unit, we can cancel them. And my answer comes out to be 5.0, and my units there are milliliters. For my answer, 2 sig figs from that 8.0, and that's set up. So I should take 5 milliliters of that 0.016 molar stock solution, transfer it to the 100 milliliter volumetric flask, and add additional solvent until I get to that 8.0 times 10 to the negative 4th concentration at the same time that I get to that 100 milliliter mark. Okay, so one type is trying to figure out which pipette size to use. That's what we've set up here. Another is when you actually do the solution preparation, what concentration do you end up with? So again, this is by diluting a stock solution, I'm seeing a concentration. And so it's going to be an M1 V1 equals M2 V2. And let's start with that. I'm going to go ahead and just give this volume the first set of conditions, V1. And now I'm looking for the concentration that goes with that 5 milliliters. And of A keys me in that this 0.016 is the concentration at that same set of conditions. We have a total volume there. That's after dilution, diluting to that total volume. And that concentration that we're asked about is that new concentration of that 100 ml solution. And so that's the M2. Asked to solve for M2. So divide both sides by V2. M2 equals M1 V1 over V2. So my M1 is 0.016 molar. My V1 was 5.00 milliliters. And my total volume after dilution that goes with my concentration after dilution is that 100.00 milliliters. The milliliters cancel. I'm left in units of molar. And my answer comes out to be 8.0 times 10 to the negative 4 molar. Okay. There's several other varieties of how we can do these, but again, look for a dilution problem being something where it's talking about taking one solution and adding more solvent to get a lower concentration. And then figure out the pairings. The most common mistakes are mixing up the pairings. And then sort out and do some basic algebra and plug in your numbers.